Pilot dive suit, you're wet.
Ready to pull the pin?
Thruster check, please.
Pilot has control, ready for release.
Pull pin, please.
Pilot sees lines are clear, pushing ahead.
Clear. Thank you, pilot.
It's interesting as we explore here some of the scientific questions behind what we're looking at and that we wish to look at more fully in the future are where are the corals and why are the corals there? You'll hear us a lot talk about patchiness, and this is kind of the name of the game. It's a very patchy environment down here. Sometimes you see lots and lots of these organisms in high density and quite a lot of diversity, and sometimes you just see one or two or three. And so our challenge as scientists is to understand better why that's the case. So this is really nice. It looks like we're about to have a close look here at a sea urchin. You can see some of the spines there are modified at the tips. And the thought there is that it's a little bit thicker and allows it to move through the sediment a little bit more easily. There's a just exquisite view of the polyps. So the brighter orange dots that you're seeing in the center, that's the mouth leading into the pharynx. And you can see these white needle-like structures on both the body of the polyp and sticking up between the tentacles. Those are called sclerites.
You can see the water moving across the face. That is
sure.
That is the current mostly. I don't know if I'm causing that.
Thank you.
Hey Scott, exciting day for starfish today.
Yeah, it is. So what did you think of that white one?
The thing you just saw, the purple whitish thing with that central opening on the center. I think that might be a relatively rarely known starfish called Peribalaster. Really just kind of a delight to see it sort of right there in front of me. And who knew that it was kind of this white purplish color? Really exciting.
We're on a wall here in McMaster Canyon. Our depth is 1,234 meters. The temperature in the water column is 4.2 degrees Celsius, and we have a salinity of about 35.8. Just a beautiful, nice view of the bamboo coral. So you can see that we have reacquired the wall here. It is relatively steep. If you have a look in the Sirius cam on feed 2, you can see the scale of this thing.
Get a nice view of these differential erosion layers here.
Yeah, you look over in the Sirius view, there's a whole series of steps still.
Yeah, this is hard. So again, as a geologist, it's useful to be able to correlate layers that we see in different locations with each other to get a sense of a much larger regional stratigraphy. And that's why these canyons are so useful.
Yeah, so this is a ctenophore. That's a burrowed ctenophore. So a ctenophore is a gelatinous animal that has been compared to jellyfish in the past, but unlike jellyfish, it doesn't use a bell to swim. Instead, it uses rows of cilia that it beats like tiny paddles. Hundreds of these paddles arranged in 8 rows, going from one end of the body to the other end of the body. And we've got something really good here. We've got a bamboo coral. You can see it's been stripped of the skeleton, stripped of tissue, and there is a sea urchin on that skeleton that's feeding. It looks like an Echinus urchin. Black corals, not this particular genus, but a related genus, Lyopathes from Hawaii, I think 400 to 600 meters, has been aged by Brendan Rourke out of Texas A&M. Did some work that showed the colony was approximately 4,200 years old, so they're some of the longest lived animals on Earth. So thanks everybody on shore for joining us today. Hope you enjoyed the dive, and ROV crew, thanks. That was a great effort there at the end. We saw some really exciting things on that wall.